All right, last time we had finished up how to make this, and we had gotten to this structure over here. So look at the previous video if you're wondering how we got to that point. So we're continuing from to get from this to that right there. Okay. So we're still under acidic conditions. We have now, what functional groups do we have around? Well, we've still got our carboxylic acid. We haven't done anything with that. And now we have some alcohols. Now, we should know that alcohols plus carboxylic acid under acidic conditions is an esterification, right? So it should be a clue that now we're going to do an esterification. You say, well, how am I supposed to know that? Well, what functional group do we have present at the end here? Right? Well, we've got an ester, so we know we have to convert a carboxylic acid into an ester. Okay? So let's start to do that. So we're going to do this really weird thing to begin with. The really weird thing we're going to do to begin with is protonate a carbonyl oxygen. Whoa. Okay. I'm going to just draw this a little bit closer here, otherwise I get the feeling we're going to very quickly run out of room. Mm-hmm. Okay, why did we protonate that carbonyl oxygen? Well, go look at some of the previous videos to get a little bit more idea about this, right? But the carbonyl carbon is, while it's feeling positive, once you protonate it, it's even more susceptible to nucleophilic attack, especially from weak nucleophiles, aka from an from an alcohol, right? So it's going to help us be able to attack that carbonyl carbon by protonating that carbonyl oxygen. Now the question is this, well, hey, wait a minute, right? We've got oxygen in red, white, we've got oxygen in yellow. Can either one of those attack and make an ester? And the answer is yes, they can, right? So we can either do this, right? Or we can do this. Either one of those alcohols is capable of doing an attack, right? But only one of them is actually going to attack. Now, we can get the answer from our product here, right? We see that the alcohol attached to the methyl group, right, is not involved in this, but the question is, well, why not? Why not? Why isn't that alcohol attached to that, the same carbon as that methyl group capable of doing the attack? Well, let's answer that for just a second. So I'm going to erase this here, okay? If, I'm going to zoom in here, if my oxygen in yellow attacks my carbonyl carbon, 1, 2, 3, 4, right? It is 4 atoms away. I'm going to make a ring that is 4 atoms big, right? So I'm basically going to end up making a cyclobutane type structure. Well, that's not that stable, right? A 4-membered ring, not that stable. So we would have to have a good reason to do that. However, if this swings around and grabs that, what happens then? 1, 2, 3, 4, 5, 6. Aha, now we can make a 6-membered ring. Remember, 6-membered rings are the best, 5-membered rings pretty good also, right? Anything other than that, you better have a good reason for doing it, okay? Okay, so let's draw the product of this here, right? So I'm going to kind of tweak things around a little bit here. I'm going to kind of twist things. There's my carbonyl. Okay. Hopefully you guys caught what I did here. Let me help a little bit, right? Blue is there, right? I'll do yellow, right? Yellow. Right, hopefully all you guys saw is, see what I did in drawing is I just basically swung that blue up and then swung my oxygen down there, right? Okay, so now we're going to do the proton shuffle again, right? We popped up a pi bond here, right? We popped up a pi bond here. So we know we want to fall back down and kick off the best leaving group. So proton shuffle time. Okay. We did this. We have this. And now this. And this. Okay. Here. Here. Mm-hmm. There. We made the pi bond in green. Still got our black right there. And then last but not least, that. And I'm going to take a shortcut here and point to right there, okay? I can fill in some of the colors here, right? There's the pi bond we made. Here's the red bond right down there, right? Fantastic. All right. Good. That was a tricky one. Certainly was a tricky one. So the key points to recognize is I need you guys to spy the hidden carbonyls. When you guys see an acetal, they're protecting groups. They're protecting a carbonyl group, right? And you need two alcohols around, right? You need two alcohols around plus a carbonyl group, and those three things combined will make that right there. Right? Cool. All right. I'll see you guys in the last video of page 4 here.